Hello friends, today we shall discuss about some of the important patterns of evolution. Number 1, convergent evolution. Number 2, divergent evolution. Number 3, parallel evolution. What we call evolutionary patterns. Evolutionary patterns. We have discussed in our previous classes, evolution is nothing but descent with modification. That means organisms keep on evolving themselves in tune of changing environmental conditions so as to evolve into a better organized and adaptable species. Okay? And regarding it, there are different lines. Say, pattern, what we call. Number 1, convergent evolution. Number 2, divergent evolution. Number 3, parallel evolution. Parallel evolution. Okay. Convergent evolution. The name it implied, converge. Who converge and in what way? Here in convergent evolution literally means organisms, they evolve similar characters based on similar environmental features by the individuals belonging to different groups or completely unrelated groups. Phylogenetically, they doesn't have any specific lineage linkage. That means ancestral relationship. They don't have any particular ancestral relationship, but still they tend to evolve similar characters because they inhabituate similar environment. That is very important. What we call, I told you already, adaptable characters. According to the changing environmental conditions, organisms has to adapt. No matter whether they are coming from one particular ancestor or a different ancestor. This is what happens in convergent evolution. That means evolution of similar characters based on similar environment by the individuals of completely unrelated groups. The typical example, what's called the classical example with respect to convergent evolution. Wings in insects. Insects actually, they are invertebrates. Birds, that means here, flying reptiles, birds and flying mammals. They have different ancestors, but they still evolve into common characteristics because aerobial flight adaptations is their necessity. According to the kind of environment they have to evolve. That's the best example for convergent evolution. Wings of insects, flying reptiles, birds and flying mammals. But we are going to discuss at length about this topic. Say, in plant groups, there are mangroves. In case of animals, apart from these examples, say we have fish, say both cartilaginous fish or bony fish. Then Ichthyosaurus, extinct aquatic reptile, dolphins and aquatic mammals. In case of animals, we can see fish, Ichthyosaurus and dolphins. What are the common characters? They have a mid-dorsal fin, they have caudal fins. For example, most important character, streamlined body form. What we call fusiform. Mid-dorsal fins, caudal fins and others. Here we told, that means we have discussed that evolution of similar characters, or the characters are completely similar or there is just a mere superficial resemblance. there is a superficial resemblance, because fish is a different group, Ichthyosaurus is a different group, dolphins are different groups. They tend to exhibit superficial resemblance based on certain morphological characters which enables them to evolve or to fit in the concerned environment. That means the aquatic environment. That's it. But inside, that means in depth, they have different anatomical features, different body organization. Apart from this, based on the superficial resemblance, that means superficial resemblance is because of the kind of environment, that means similarity of environment, they tend to evolve common characters. So this is very important. Okay. Then in case of plant groups, another typical example is mangroves. We all knew that mangroves are called biobarriers. Biobarriers to tsunamis, floods, and other sea inundations. Biobarriers, mangroves are called. Biobarriers. What are mangroves? They are salt tolerant halophytes, inhabituates in estuaries. Our mangroves are all coming from one common ancestor? No, they belong to different ancestors. Say, we can discuss point by point, okay? Say Rhizophora is one mangrove. Bruguiera, Lumnitzer, Sonaratia, etc. They are actually they don't have a common ancestor. Rhizophora, Bruguiera, Lumnitzer, Sonaratia, and others have a different ancestors. These different ancestral forms evolved into a group of organisms having common characters. A group of woody communities having common characters are called mangroves. Say, systematic presentation I would like to give. Say this is one common ancestor. This gives rise to two. That means two species, B and A. This is another ancestor. It gives rise to two species, say X and Y. This is another common ancestor. This gives the two species, say C and Z. Here A and B are different, but B and X are similar. Same like C also. Why B, X and C are similar? Actually, they belong to different ancestors. They don't have, as I told you, they don't have any phylogenetical relationship, but they have similar characteristics. They belong to different ancestors. Why? Because of commonality. What is that commonality? The environment, the estuarine environment. Say the hypersalinity, the daily tidal fluctuations, hypoxic conditions or underoxygenic conditions, unstable substratum. These are the extreme environment. That means estuaries, they transit the marine terrestrial interface, and in this extreme transitional zone the mangrove prevails, and to adopt the same they must have specialized in characters like nematodes, which enables mangrove to give strength, that is unstable substrate in the form of mechanical strength, and also oxygen transport to deeper tissues. This is how the issue ends. They belong to different groups, I told you now, but they have a common character. That is a typical example of convergent evolution. Okay, next is divergent evolution. The name it implied. Divergent. See, it is one ancestor, common ancestor, leads to two different species. But the thing is, the phenotypes of these two species are different than that of their common ancestor. Phenotypically different. phenotypically different. For example, we have a limb, that means four-limb and hind-limb, say limb in human being. Here, whale is also, Belnoptera is a whale, is also a mammal. This limbs modified, that means evolved into flippers. Though we have a though we have a phylogenetic relationship because we are mammals, but our structural organization is different. Our external characteristics and morphology is different because we inhabit different ecosystem, the different environment. Say we are terrestrial beings, whereas whale is an aquatic being. And most classical example to discuss for better understanding is Darwin's finches, Geospiza. Most classical example. Say there is a common ancestor which is seed eating ground finch. Okay, and this seed eating ground finch, say it is South America, it is Ecuador, these are Galapagos Islands. Say one group of island, Isabella, another island, okay, archipelago, group of islands, Santa Cruz, another island, Santiago, another island, Pinta, another island, Espanola, Isabella, Santa Cruz, Santiago, Pinta, Espanola. They are different islands of Galapagos. They don't have connection. There is a geographical barrier in the form of ocean. That means different finches. That means actually once upon a time there is a common ancestor. This Geospiza, they isolate a group of isolate and inhabit different islands. Say Espanola finches are different from Isabella and also Santiago and Santa Cruz and Pinta. Say how it works. Say one common seed-eating ground finch gradually evolved into different finches. Say pre-finch, woodpecker, like finch, cactus feeding finch, warbler, like finch, insectivorous finch. What is the main basis for these different finches? How can come to a conclusion that they are different species? Say based on certain observation, that means morphology factors. Beak is most important here. Beak, based on the different beaks, we can identify different species of finches, that means Geospiza. Say insect is, for example, woodpecker like finch. The beak is stout, strong and long. Woodpecker, it tend to make holes on the large woody plants, strong wooden plants. The same way, because of the necessity, it developed strong, that means stout, strong and long beak, and it is actually basically an insectivorous. It feeds on insects. Okay. Another example, warbler, slender beak. The beak is slender and is basically an insectivorous. Another example, the vegetarian finch. It developed short, thick, parrot-like beak. Because this short, thick, parrot-like beak enables the vegetarian finch to break down the, it has to feed on fruits, seeds. So based on the kind of feeding, the beak develop. Say in case of warbler, slender. In case of woodpecker, stout and strong. So based on different beaks, we can classify that we can identify different species and how they evolve into different species. And it is the best example, the typical example for divergent evolution. One common ancestor which is seed-eating, this splits into different groups. What is divergent evolution? Based on concept, we can simply say here splitting of a lineage into different evolutionary pathways that ultimately leads to species. Different evolutionary pathways because of different environmental conditions. This is very important. Different environmental conditions. Say here the necessity is vegetarian. Say it is insectivorous. So according to the kind of environment and kind of feeding habits, they evolve different characters. Ultimately, they are different from common ancestor. That's how they evolve, and it is the best example for divergent evolution. Okay, and you can simply represent like this. Then one more important pattern, that is called parallel evolution. Parallel, the name it implies. Together, simply it means parallel evolution. Say there is one common ancestor. It develops into two different groups, and they develop similar features. Say this is A and this is B. Similar phenotypes. But the thing is, unlike convergent evolution, here in parallel evolution, evolution of similar characters in related organisms. This is very important. They are coming from one common ancestor. For example, say in arthropods, I will tell you how it works. Okay, but with the basic concept I am saying, evolution of similar characters on similar lines because of similar environment, coming from one common ancestor or closely related beings. Their lineages are distinct, but they have some relevance, and they have some relation. There is a phylogenetic relationship. But the thing is, they evolve together. Similar characters. This is very important. Say echidna, the best example. Anteaters. Say mammalia. We class mammalia, there are different groups of groups like protothelian, metathelian, and euthelians. Okay? Echidna. This is protothelian. Myrmecobius. This is metathelian. Myrmecophaga. This is euthelian. Actually, they are mammals. I told you there is a common ancestor, but there is a relevance. There is a phylogenetic relationship. But they evolve together based on similar environmental requirements, what called adaptable characters, similar adaptable characters. Say long snout. Since they are all anteaters, there is necessity of evolution into one group of characters that are common. Long tongue, clawed digits, and snout, long snout. This enables them to feed ants. This is how it's a echidna, it's a protothelian, Myrmecobius is a metathelian, Myrmecophaga is a euthelian. Of course, there are mammals, so it's the best example for parallel evolution. Okay. These are the major evolutionary patterns. We must also discuss about two different words, what microevolution and macroevolution or mega evolution. Evolutionary changes occurring at the species level is microevolution. It means changes within the population of a species that leads to subpopulation, evolution of subpopulation and ultimate species. That means taxa, rank is species, but mega evolution means evolutionary change higher than the rank of species. say family genus higher than species rank, higher taxa evolution. Say at the genus and family level, it's mega evolution. Okay, so these are different evolutionary patterns. You may like, comment or subscribe. Okay, thanks for watching.